So Lou Amadio is with Microsoft, and he's going to be sharing a little bit of work about what's going on in his team, leveraging the Mixed Reality Toolkit. So Lou, it's been sort of the HoloLens show today, right? So it should be a natural just dovetail into your work.
That's absolutely, that was fantastic to see other consumers of the HoloLens. So I'm going to talk a little bit about how you will be able to leverage the HoloLens in your applications in the near future. So let me go ahead and share my screen. Let's see how this goes. There we go. So hello, everyone. My name is Lou Amadio. I'm a principal development lead at Microsoft in the Azure Edge and Robotics team. Our focus has traditionally been on bridging Microsoft technology and ROS together, including our initial support for ROS on Windows. We do some work with actually, let me share our landing page, Visual Studio Code extension, Connect, machine learning, DevOps, virtual machines for Azure. But today we're going to talk about the Mixed Reality Toolkit with ROS-I. You might not know much about the Mixed Reality Toolkit and how ROS-I works with it, so I'm going to just touch on this really quick. It's a little bit of a rehash of our Tuesday, but we'll get into some demos in a second. So what is the Mixed Reality Toolkit? It is a framework for building mixed reality applications. It contains many different primitives that you can use to build your applications, from basic UI building blocks, human interaction, primitives for building 3D objects, collections, shaders. It's a fairly powerful solution, and also provides some understanding of the environment, which is what we're going to be leveraging in the Mixed Reality Toolkit for ROS. Okay, so how does the Mixed Reality Toolkit for ROS work? Well, of course, we're using ROS-II. We're all in on ROS-II. We love it. It's awesome. I look forward to the ecosystem transitioning over to it. For the Mixed Reality Toolkit for ROS, there is no component that necessarily needs to run on the robot. Although one of our partner teams does provide a spatial anchor service for the robot that allows you to use the cloud to share position. So we're going to focus on the right-hand side of this. At the very bottom, we're providing a Nuget package, which is a standard interchange format for Windows-based applications that contains ROS-II that has been compiled for the universal Windows platform. This is critical for the HoloLens, but it also allows you to deploy to things like a Surface Go or some other technology. We've been working with a couple of companies, including eProsima, to make sure that the FastDDS middleware runs well on the HoloLens. And part of this was actually brought up by friends of ours in the ecosystem. So Sean Kelly and Estev Fernandez. That native portion is C++, and I'll show you how you can use the native portion to talk to ROS-II. But when you're talking about Unity, Unity is built on C#. So how do you make it easy to consume in a Unity application? Well, Estev Fernandez also bootstrapped ROS2.net, which is native bindings for ROS-II in C#. Between these two, you actually have the building blocks necessary to start doing pub/sub into a Unity-based application running on the HoloLens. We're providing, on top of these features, as well as contributing to these other features, is a set of UI primitives that are specific to robotics. This is the building blocks that you can use to build your application. You can build commercial applications, you can build open source applications built on it, but these are the common building blocks that we're providing. So one of the common building blocks that we're working on is spatial pinning, because ROS maps, ROS space and holographic space are totally different. So how do you get these two spaces to communicate with each other so you can transform between robots and holographic space? Well, we're using a QR code or the spatial anchors to provide that common pinning between those two spaces. So for open source non-cloud connected, you can use QR codes. which will give you the pose of the QR code relative to robot space that the HoloLens would then use to actually understand where ROS world 0 is, so that you can set up the transform graph, and then you use TF just like you would any other one. Okay, so that's actually the end of the slides, and I'll talk about demo now. If you want to learn more about the other work that our team is doing, go ahead and check out aka.ms/ROS. And what I'm showing here is really raw. It's about taking some really manual steps that are hard to get right and require a lot of direct interaction and making it easy to consume. Okay, so what I'm going to show right now is, let's go ahead and go over to a UWP application. So the Universal Windows Platform is a application model for Windows that is relatively constrained. It's designed at its onset to be super secure and make it so that you have all of the understanding as a user what the application is going to do with your data and with your environment. So with that comes constraints on how you can actually build applications. So part of our work is how do we actually adopt those limitations of UWP and make it available. So that's what we've been working on, is making it so that these ROS-2 actually runs natively. So I'm going to install a Nuget package, that common interchange format, into a universal Windows application. And you can see that this is a native minimal subscriber. I have a Jackal running ROS-2 over here that is doing just a simple pub sub. And we're going to recompile this after installing the Nuget package. And hopefully the demo gods are going to be happy with me. Takes a second. Okay, so with that, what we're demonstrating here is that native portion of ROS-2 running in a universal Windows platform, which is a precursor to run on the HoloLens. And as you can see, once it starts up, it will be subscribing from the robot, the simple publisher with a simple subscriber. While that's firing up, is there any questions so far? So I'm going to switch over to Unity while that's firing up in the background. The Mixed Reality Toolkit supports both Unity and Unreal. The Unreal lags a little bit behind the Unity plugins. We've been working with the Unity technologies on enabling the Unity Package Manager for ROS-2. So how does that work? Well, the Unity Package Manager is kind of like NuGets. They are packaged versions of code that includes not only the native plugins, but also your basic scenes and UI plugins. So here you can see like the Mixed Reality Toolkit examples. We have a ton of samples available. The Mixed Reality Toolkit ROS extension will appear in here. You'll be able to select it and then add different demos that we'll be providing that wrap some of the UI framework that we have. Once it's imported, then you can go ahead and drag something like the slate scene is one that has been provided that gives you a basic understanding of how to use slates from the UI framework or from Unity. Okay, so let me go ahead and remove that scene. And do I actually have it pub subbing? That is taking a really long time to start. So so flipping back to Unity, once you have your application set up, and here I have this uses the Webotics API for communicating with the charger that the Jackal is connected to. We have the game object set up that does mapping as well as connecting to the WeBotix sensor packs. I have built this in the past because it does take a while to deploy. So I'm just going to go ahead and fire up the HoloLens and run it, and then hopefully be able to show it. So while that is firing up, there we go. My network seems unhappy right now. Okay, so what you're seeing is a live preview of the HoloLens. And then we are going to do a remote run. So while that is firing up on the other side, I'm showing the native Nuget package running and consuming data off the Jackal. Okay, so sorry about switching back and forth. I was trying to keep it in time without a lot of waiting. Okay, so native Nuget package running in UWP, consuming ROS-I. And now on the flip side, we're still deploying.
The beauty of live demonstrations.
Yeah, I should have recorded this and fast forwarded through the deploy.
Oh, that's okay.
This is
I mean,
going to take a while, so I'll just.
While the sausage is made.
Yes, while the sausage is made. Why don't we go ahead and call that? It's going to take. I didn't think it was going to redeploy the entire thing.
Well, I have a question though, Lou. Do you mind?
Yeah.
So if I hit, let's say hypothetically, I have a legacy ROS-I system, and we're interested in adding like a kind of like a HoloLens type capability to it. So I mean, what would be like your, like I still have ROS messages. Like what would be your kind of preferred method for communicating with the legacy ROS system?
So what I would recommend doing is actually installing the ROS-I bridge on the robot. The running ROS-I natively on, oh, actually, let me take a step back. If you are running just ROS-I, there is the ROS-Sharp solution, which actually allows you to use a bridge with the ROS bridge on ROS-I. It works fantastic. This is about running ROS-II natively on the HoloLens. So if you do need to mix them, it's actually possible to run ROS-I using ROS-Sharp and ROS-II natively in the same application. We have actually demonstrated that. But the ROS-II running natively actually does the direct pub sub from the HoloLens and bridges directly into C# so that the latency is significantly lower than kind of that triple hop that you see through ROS-Sharp to the web server to the ROS bridge to the pub sub on the other side. So the latency is significantly less when you actually can do direct pub sub.
Lou, I actually have a solution for direct native access to ROS-I and C#, if you want to take a look at it.
Sweet. I would like to take a look at that. We're definitely having a recommendation for customers interested in that would be fantastic. But yeah,
John,
our focus has been on ROS-II native.
We may be in touch as well, John.
So as you can see here, we have the HoloLens is talking directly to the WeBotix APIs to actually show the live sensor data off of that. So anyway, that is the demo so far. Go ahead and stop screen sharing. Our goal is to make it so that using holographic user interfaces becomes ubiquitous. I do believe in the next few years that we are going to see a explosion in AR solutions, and we want to make sure that we're setting up people to be successful in the future. So take a look at our GitHub or our landing page at aka.ms/ROS, and feel free to reach out. We do monitor both Reddit and ROS answers. So thank you very much for your time. I appreciate it.